Dear students, under the lecture series on graph theory, here we have lecture 5. The theorem states that every cubic graph has an even number of vertices. First, we shall understand this theorem with the help of an illustration. Here we have taken two graphs. Let us name the graphs. This is vertex V1, V2, V3 and V4. If you see what is the degree of this graph, you can see that the degree of this graph, this vertex is 3. Similarly, the degree of this vertex is also 3. And this is also 3. And this vertex is also 3, which implies that this graph is a cubic graph, because we know that if all vertices are of degree 3, then it is known as a cubic graph. Now we shall count the number of vertices in this graph. If you see, we have 1, 2, 3, 4. 4 number of vertices, which is an even number. Similarly, we will consider this graph. This graph has 10 vertices, and if you see, each of the vertex has degree 3. So everywhere if you check, the degree will be 3 only for all the vertices, which implies that it is a cubic graph. Now the number of vertices is how much? It is 10. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is an even number. So this is the illustration for every cubic graph has an even number of vertices. Now we shall proceed with the theoretical proof of this theorem. Okay, the first step will be as usual, that is, we have to consider a graph G. And since we are considering a cubic graph over here, let us write it as let G of V comma E, okay, be a cubic graph. Usually we will take let G of V comma E be a graph, but since we are concerned about cubic graph in this theorem, we are taking G of V comma E as a cubic graph. So from this, what do you find? Because it is a cubic graph, each of the vertices will be of degree 3. So let us write that here. So that we have written. Since it is a cubic graph, every vertex will have degree 3. So that's why we have written each vertices of G is of degree 3. Now we want to prove that the number of vertices is even number. For that, let us take P as the number of vertices. Okay, let us take small p be the number of vertices of G. So number of vertices of G. So now since we have taken P as the number of vertices of G, we have to prove that. So what we have to prove? We have to prove that P is an even number. So to prove P is an even number. So first we took an cubic graph, and since it is a cubic graph, it is of degree 3. Now the number of vertices we have taken as P. Now we have to prove that the cubic graph has even number of vertices, which means that the number of vertices P is an even number. That is what we have to prove. So now in order to prove that P is an even number, we are going to make use of the fundamental theorem of graph theory. Okay, what does the theorem say? Summation degree of Vi for Vi element of capital V is equal to 2Q. So this theorem we are going to make use of. Now we know that if we add all the degrees of the vertices of this graph, it will be equal to 2Q. And this is what? This is an even number. So we are going to make use of this. So let us write this to be equal to an even number first. So therefore, summation degree of Vi for Vi element of capital V is equal to an even number. Because it is equal to 2Q, it will be equal to an even number. Now what is the summation degree of Vi? It is the sum of the degree of each of the vertices of this graph. Now we know that the graph that we have considered is a cubic graph. Then what will be degree of each of the vertices? Each of the vertices will have degree 3. So when we sum up, it will be 3 plus because each vertices is of degree 3. And how many 3's we have to sum up? We know that it has P number of vertices. So P number of times we have to sum up this 3. So we are summing up 3 p times, and that will be equal to an even number, obviously. So obviously it will be an even number. So when we sum up 3p times, it will be 3p, and that is equal to an even number. And when can this relation be possible? Only if p is an even number, because 3 is an odd number. So if you want an even number, then you have to multiply 3 with an even number in order to get an even number. So with this case implies that p is an, so this is possible. So when can this relation be possible? It is possible only if p is an even number. So if you multiply an even number with 3 only, you will get an even number. If p is an odd number, you will get, for example, if this is 3, you will get the answer to be 9, which is an odd number, but we don't want that. We want an even number. So obviously, if for example p is equal to 2, then it will be 6, which is an even number. So this relation is possible only if p is an even number, which implies that the number of vertices of a cubic graph is even, because the p was the number of vertices that we have taken. So p is the number of vertices, and so number of vertices is even, which implies that every cubic graph has even number of vertices. So let us write that and conclude this theorem. So we conclude that every cubic graph has an even number of vertices. So hence proved. So I hope you would have understood this theorem. This is one of the significant theorem under graph theory. In our next video lecture, we will learn some problems under this topic. Kindly follow the upcoming video lecture. Thank you.